Okay, so this is Algebra 1, Semester 2, Section 8.6 only. This is more factoring of trinomials, but with a number in front of the coefficient a. So the ax squared plus bx plus c. We factored where the a was 1. Now we're going to factor where the a is going to be more than 1. And we're still going to use the diamond method. So we learned that last class. So let's go right to it. So for got it 1a, they give me 6x squared plus 13x plus 5. So remember, this is in the form of ax squared plus bx plus c, right? And the way that the diamond method works is that in the top part, we're going to multiply the a times the c. And in the bottom part, we're supposed to find whatever the a times the c is going to sum up to the b. The one on the left, we usually put the lower of the two terms that we find in the factor, and the one on the right, put the higher of the two factors. So in this case, our a times the c is 6 times 5, which is 30. And our b, I'm going to move this up a little bit, and our b, I'll move it right here. Yeah. And our b is 13. So I got to find a factor that when I do the factors up gives me 30, but when I add them up gives me 13. So one factor is 1 times 30, and if I was to add those two guys up, I would get 31. 2 times 15, if I add those up, I get 17. 3 times 10, if I add those up, I get 13. Yay, so this is the one. So that means that my factor is going to be 3. Usually the lower number is first to the left, and then 10. So there's two ways. There's actually a multitude of ways once you get to this point to move further. I'm going to do two. One that the book does, and then the one that I've seen done that seems to help kids. We're going to rename this. Now that we have our factors 3 and 10, we can rename this expression and call it 6x squared plus 3x plus 10x plus 5, right? 3 plus 10 equals 13. 13x, 3x plus 10x equals 13x. So we just renamed that 13x to the two factors that we found using the diamond method. Then we can split this up and factor out numbers. So 6x squared plus 3x, I can factor out a number here. This plus sign stays here. And then 10x plus 5. I should be able to factor out a number here. Well, what can I factor out? I can factor out a 3, and I can factor out an x. So this turns into 2x, right? 3x times 2x is 6x squared. I divide out the 3x, that turns into a 1. Here, I can factor out a 2. So I factor out the 2. 10 divided by 2 is, I'm sorry, I can factor out a 5. Whoa. That'd be a 5, that is. 5 divided by 10 is, 10 divided by 5 is 2x. 5 divided by 5 is 1. So notice what I have here. I have 3x times 2x plus 1, 5x times 2x plus 1. 2x plus 1 are the same. I can add these two terms since they're both being multiplied by 2x plus 1, so I can say that my the binomials is 3x plus 5 times 2x plus 1. And this would be my final answer. Sometimes people get confused by the factoring part of this and get a little lost. Sometimes people get lost with rewriting the initial equation. There is another way that's it's faster, but it's sort of counterintuitive. So here's how you do it. So the first number, the first coefficient of our expression is 6. And the variable is x. We're not going to write x squared, we're just going to write it as x. The two numbers, the two factors that we found were 3 and 10. So what we're going to do is we're going to write a fraction. We're going to divide it by 3. And what we're going to do is we're going to simplify this fraction. 3 divided by 3 is 1. 6 divided by 3 is 2. Well, look what I have here. I have 2x and I have 1, just like this expression here. So I can sort of rename it. And I can say, well, 2x in the numerator plus whatever is in the denominator. In this case, it's 1. 2x in the numerator plus whatever is in the denominator after I simplify my fraction. That's my first one. Then, for the second one, I'm going to write my 6x again. And I'm going to divide it by my second factor that I found using the diamond method. And I'm going to simplify this fraction again. I can divide top and bottom by 2. 10 divided by 2 is 5. 6 divided by 2 is 3. So when I rename it, whatever in the numerator is going to be first, 3x. And whatever in the denominator is going to go last, 3x plus 5. 3x goes in the numerator is first, 5 is in the denominator, and it goes last. And then these are my two factors, and I can say that this is my answer as well. It's a neat little trick, and it's a little bit faster than to do it this way. I will show both in this lecture. A lot of people who don't like to separate and factor things out like this way, a lot of people who like to factor like this way. So I'm going to give you the option, and you decide. Okay. Next example that they have for us is factoring when you multiply the two and they're negative. So for this one, they give me, for number 2, they give me 10x squared plus 31x minus 14. Minus 14. Using the diamond method, remember that the number up top is the multiplication of the a term, right? So this is ax squared plus bx. In this case, it's minus c. So it's going to be the a times the c. In this case, it's going to be 10 times negative 14, which is negative 140. That's too small of an x. Negative 140. Oh my goodness. And in the bottom, it's going to be the b term, which is positive 31. Positive 31. So now I got to think of some factors that when I multiply them, I get negative 140. And when I add them, I'll get 31. And you can just go down in number order. Since it's going to be a positive number, my smaller number has to be negative. So negative 140 times, or 1 times 140. When I add them up, I get 139. Negative 2 times 70. When I add them up, I get 68. And it doesn't work for 3. Let's try negative 4. negative 4 times 35, which gives me negative 140. If I add them up, I get 31. So that seems to be the thing that works. So this is going to be negative 4, and this is going to be 35. So when I split this up, I can do 10x squared minus 4x plus 35x minus 14. Could put parentheses around it, think of something that I can factor out. In this case, I can factor out a 2 and an x. So 2x, this turns into 5x. That turns into 2. Here I can factor out a 7. That turns into 5x. That turns into minus 2. Look at that. 5x minus 2, 5x minus 2. They're both being multiplied. 1 by 2x, 1 by 7. So I can write it as 2x plus 7 times 5x minus 2. And that's the book way. And that works. Again, if you want to try it that other way, we look at the first a coefficient, which is 10. Call it 10x, the variable is x, and I can divide it by negative 4. Simplify this fraction. This turns into negative 2. This turns into 5. So the numerator goes first, 5x. The denominator goes second, minus 2. Hey, and it looks just like that one up there. Again, start with that 10x, the a coefficient, and then the variable. Remember, it's not going to be squared. And I can divide it by 35. Simplify, I can divide top and bottom by 5. This is going to turn into 7. This is going to turn into 2. So the numerator goes first, 2x, and then the denominator goes second, plus 7. Hey, and I got the same thing right there. So both apply, both work. One is a little faster than the other, but they both get you to the same place. Okay. They give me another example. We're going to do 2 more, maybe 1 more, and we'll be done. And we have, they want the dimensions, and they want us to use factoring of 8x squared plus the 22x plus the 15. If we do our diamond method, 8 times 15, remember the a times the c term, is equal to 120. And when I add these guys up, it's going to give me 22. So going down the whole factor line, and of course that was going to happen. I had a feeling that was going to happen because it's just what happens when I mess around. Okay, we can try one number. When I multiply them, gives me 120, and when I add them, gives me 22. So we got 1 and 120. When I add them up, I get 121. We got 2 and 60. When I add them up, I get 62. 3 and 40. When I add them up, I get 43. And this is going to go on for a while, so I'll just go all the way to the end because there's like 5, 4, 5, 6, 8, and then what if I did 10? 10 times 12, which is also 120. When I add them up, I get 22. Hallelujah. So it's going to be 10 and 12. rename this 8x squared plus 10x plus 12x plus 15. By the way, if I was to switch this and not go from lowest to greatest with the factors and did 12x plus 10x plus 15, you would get the same answer. I can divide this by 2x, these two, which gives me 4x plus 5. I can divide out here a 3, which gives me a 4x plus 5. Yay, look at that. 4x plus 5 is being multiplied by 2x. 4x plus 5 is being multiplied by 5x. I can factor out the 4x plus 5, and that would give me 2x plus 3 times 4x plus 5. And it works. Good. Again, if you want to do it the other way, the a coefficient, which is 8, the variable, which is x, you could try to divide it by 10. These guys can be divided by 2, so that's a 4, and that's a 5. Whatever is in the numerator is first, so that's a 4x. And then in the denominator goes second plus 5. That's the first term. Then I can also do 8x, the a term and the variable, and divide it by 12, and then simplify, again dividing by, in this case I'm dividing by 4. 12 divided by 4 is 3, 8 divided by 4 is 2. Whatever in the numerator is the first term, 2x, and then the denominator is the second term, 3. And look at that, it looks just like the first one. Again, whatever method makes you happy. I think either one of these two are equally effective. Alright, I think we have one more example, and then we'll call it a day. So now, these are problems in which you can factor out. I mean, you can do it with the 8 and the 20 and the 36, but if you notice they all share a common factor, you can factor it out and make your diamond method a little bit easier for you and less stressful. So I have 8x squared minus 36x minus 20. All of these are divisible by 4, so I can factor out a 4. So I pull out a 4, that turns into 4x squared. Sorry, it does not turn into 2x squared. That turns into 9x. That turns into 5. So now I'm going to use the diamond method with this in here. Now just to recap, I could have used the diamond method with this. It just would have been bigger numbers with a lot of factors and getting lost and stuff. It is always easier to factor out and make it as small as possible and then use the diamond method whenever possible. So with the diamond method, 2 times negative 5 is negative 10. And I gotta think of a number that multiplies to negative 10, and when I add them gives me negative 1. So when I think about this, it has to multiply to negative 10, and then when I add it, gives me negative 9. That tells me that the bigger absolute has to be negative. So if I do negative 10 times 1, that gives me negative 10. And if I was to add negative 10 plus 1, that gives me negative 9. So that's what I'm going to go with. So this is negative 10 to the left, 1 to the right. So when I rename this, I'm not renaming the top part. I'm renaming the 2x minus 9x minus 5. I'm not going to worry about the 4. I'll bring it back later. So this is going to be renamed 2x minus 10x plus x minus 5, and then put the parentheses around and see what I can factor out. Well, here I can factor out a 2 and an x. That's a square, which gives me x minus 5. Here I can't really factor out anything, so we can pull out a 1. So we basically put a 1 here, and 1 is x minus 5. Remember, anything can be multiplied by 1. So 1 times x minus 5, 2x times x minus 5, they can factor out the x minus 5 and say that it's 2x plus 1 times the difference of x and 5. And that's it. Oh, no, that's not it. See what happens when you forget that silly little 4. That 4 is still floating around, so to finish it off, you have to multiply everything by 4 because this is our original problem. Again, that's a common mistake, and I just made it. When you forget about it, sometimes you don't put it in your final answer. Don't be like me. Okay, so that's 4 times the difference of x and 5 times the sum of 2x and 1. Again, doing it the other way, you have that 2, right? The a term and then the x variable, and I can divide it by negative 10. And simplify, that turns into negative 5. That turns into 1. So the numerator is the first term. The denominator is the second term, including the sign. So if it's negative 5, it's going to be x minus 5. Again, 2x for the a term and the variable. In this case, we're dividing it by 1. Can't simplify that any further. So it's going to be what's in the numerator is the first term, plus, in this case, whatever is in the denominator, which is 1. Hey, look at that. And don't forget that 4. 4 times the difference of x and 5 times the sum of 2x and 1. And that is using the diamond method when you have a variable in the a term. I think I'll stop right there. You guys have a great rest of your day.